Okay, looks like the next part of this project now is to find a way of how I can secure this here piece in position here when I go to do the drilling, and I'll probably use some sort of a bolt to hold that in position, and we'll see what we can come up with. I have to decide of how deep I'm going to make this hole, because this large hole here, this is a very thin wall from here to here, so I can't go down too deep in there, so I'll have to do some measurements here and see what comes up for that. Right now I'm drawing the center line down through here. I can use this to line up the cartridge holes whenever I go to do the drill bit, lining up. Remember, I made these here lines across the center of the diameter of the holes here. That's what's going to line up with this whenever I go to do the drilling and the lining up, like that. Okay, and then I can do a location for the bolt, where the bolt will come down at. That should work. That should work good. I have now is my center line coming off from the hole here itself, going down, and the mark that I just made with that bolt right there is right here, and where that crosses the center line here, that's where I'll do my machining at. What I'm going to do is, I'm not going to use a drill bit because I really have not much depth when I get to this big hole here. So what I'm going to do is I'm going to use my end mill, and I'm going to put this on the angle that it's already in here, and come down with an end mill and make a flat surface on both of these areas here, and that's going to be so that that can register there whenever I put that in the fixture. Look at this. When I put this in here like this, I can see that the bottom of this right here is registering with the bottom of this, so that they're both on the same plane. This and this right here on the same plane. So that means then that I can put this down like this, and it'll still be in the same orientation it would be if it was fitting in the fixture itself. So I can put that in my vise flat to the bottom like that, whenever I secure it, and then I can machine those 2 spots. Here's what I did. I have my mark right here that the bolt made right here, that indentation. But remember now, that bolt is a 1/4 inch in diameter, and that was the, since this is on an angle, that was the edge of the bolt that made that there mark. So what I did was I lined up my center of my spindle to the edge of that mark right there, and then I moved it in this, and moved the table then this direction here, 125 thousandths, which would be half the diameter of the bolt, so that I can get the end mill to go right into the center here, so that the bolt would fit in there on center. If I were to line it up with the indentation, then I'd be up too far on the table, because the indentation is the edge of the bolt, not the center of the bolt. Okay, so now we'll go ahead and get this here flat milled right here now. I have my quill locked here now, so I have good steady stability here on the headstock, and I'm going to use the Z-axis to do the depth of cut. But as I do that, I'm going to have to watch my gauge on the other side and see how far down I want to take this. I think what I'm going to do is I'm going to go as flat as it can go until this edge of the bit right here is touching right here, and then I'll have the flat, and hopefully I won't be cutting through the hole on the other side here when I have that larger hole to work with, and we'll see how that works. About 50 thousandths depth of cut. I know now that I'm set up properly on the x-axis, lined up in this direction here. All I got to do now is just loosen my y-axis, put my center finder in here again, and move this over to the next line that is the center of the other hole. And I'll be on the same line here where I need to be then, and it'll be right in position where it needs to be. Okay, on this one here, I did not go down as deep because the hole is larger here, and I don't want to punch through the hole. I want to give myself enough material that I can clamp onto whenever I use the bolt. Alright, let's go ahead and give this a try and see what we have here. I'm locking this in position. Okay, back at the bench here now, we'll go ahead and give this a try. There's 2 slots that I made right here, 2 holes right here, spotting holes for registering, for line this up, line the center lines up here. Like that. I'll make a couple stops later on, and that lines up really nice through there like that, and that won't pull out, nice and solid. Slide it over to the next one here, line that up, tighten that down. Oops, line it up here. There's the center, here's the center of the hole. There we go, feels it nice now. And that hole lines up real well. Okay. And again, that's nice and solid, won't move out. Okay, so the next thing to do now would be to make some sort of a pin arrangement that will allow this to not, so that won't pull out, that can just slide back and forth. And probably a pin arrangement that will go one here, any slot with a stop groove, so they can stop in position as it needs to be and not pull out. And I think that'd be the next part of this project. Machining procedure. We have a very interesting setup that we have to go through here. Whenever I make this here groove in here, I'm going to put pins down through here on one on each side, and a stop groove on the top of this right here so that I can slide in between there. Now I want the stop groove to be a flat milling groove on this here piece right here. That's got to remain flat, but that goes on an angle in the fixture. So that means that this here fixture has to be tilted toward 21 degrees in order to be able to machine and be able to drill the holes for the pins that go through, so they enter in on here flat. Now I can fit this on my tilting vise in this direction here because this is cut on an angle this way, and it'd be very difficult to hold that in there and have everything registering properly. So what I got to do is I got to put that in another vise like this that will hold that, and then put this vise in the tilting vise. Okay, so what I'll do is I will put this in the vise like this. I'll lock this in position here. Let's see this. I'll lock this, make sure that's flat here, nice and flat. Also have room here. Get the piece in there to register it. And we'll tighten this. Make sure that this piece here goes in, slides in. It does, so I can use that to line it up. And I'll get a couple parallels for my tilting vise here. Got my parallels here. That will allow the vise to sit on top of, like that. And make sure that that is off. Yes, that's off the jaw there, so it's clear in there. So the angle, so the parallels keep the vise high enough so that we have the workpiece here cleared. Alright, so now we can go ahead and tilt this now to our 21 degrees until this here becomes level out through the front here. What I'll do is I will level this out on front here, and then I'll have where I need to be. Here's some small 1034 or 1024 set screws here, and that's close to about 3/16 of an inch. So that way there I can use a 3/16 inch end mill to do the stop slot in here. Go ahead and set this up now to that there 21 degrees. Should be about right there. And then we will put a gauge across here and see how close we are to being flat here, and then we'll be able to drill. Gauge across here by eye just to see what it looks like here, and that's looking very good. I would say that is a little bit. Right there. That looks good now. Alright, that looks good. I want to determine where we're going to put this here set screw. First thing I want to do is lock the workpiece in position here for this too, because I want to drill and spot a hole in on this part as well at the same time. So we lock that in position now, and we can now drill through here into here, and that will give us a mark here, and then we can thread this, and then we can move the whole table over to do the other side. The mark right there that it made for spotting that, and then that's what I'm going to use for the groove. So I'll now put this back in here again and slide this to the other hole now and lock it in position. And once I get that locked in position, I'll drill the other set screw on this side here now. That will be the other stop hole. zero stop hole. Now we can go ahead and tap this. Alright, next thing will be to mill this here groove in here now, and then we'll have the mechanical part of this done. One quick look at the setup. Okay, now these here two set screws are going to act like guide pins. And that's what these here two divots that we made in the in this part here is for. That we can go from this divot to that divot there and make a stop groove for these here two set screws that act like guide pins to slide in. And that'll be coming up next now, this part right here. Making sure this is nice and flat against the bottom here. Ensures then we have a nice straight cut. Okay, there's a slot in there. Got the glare this time. So I'm going to do the drilling first for the small hole for the screw shank. Loosen it up here, slide to the next side. That. Tighten it in. And then drill the counter bore. And what I'll do is I'll put a little bit of plumber's tape on the set screws here. Just a little bit to keep the set screws a little bit tight. I can still take them out if I need to, but I can at least have it now sliding. Okay, so the mechanical part of this project is done now. What I need to do now is start working on the profiles of cutting this part here down a little bit so I can put a clamp on there. Possibly doing some sort of a groove in here so that the chips can be ejected out. That's probably some more stuff I need to do yet. But right now I just want to get this part here done, the mechanical part of this done to this point. Okay.